Okay, welcome all of you. Hopefully you had a great weekend and we actually had no smoke, which was nice. So I enjoyed it and hopefully you had a good time too, but it's time to get back to work and we'll go over the quiz. So let me share my desktop. Okay, so here is the quiz. And the first question is if f of x is equal to x cubed times the secant of x plus the tangent of x over x, find the derivative. Okay, and I decided on this one, this is really a two-part question, but I figured I'd pop it all in one shot because you're going to have to use a product rule, you're going to use a quotient rule, and of course we have to find trig derivatives because that's what this section's about. So let's go ahead. Let me copy this. And let's find the derivative. Okay, so let's start out with x cubed secant of x. What rule do we have to use to find its derivative?
Product rule.
Yep, we have to use a product rule. And again, you are responsible for knowing the stuff we've already done. And the product rule, the derivative of f times g is f prime times g plus f times g prime. So first, the derivative of x cubed, that's the power rule. And that one, the most important, you got to know that one because it's in like most problems. So that's 3x squared. And then times secant of x. Any questions so far? And then plus, and now we need to take x cubed. And who remembers the derivative of the secant of x?
Secant x tan x.
Yeah, so secant of x times the tangent of x. Secant of x times the tangent of x. Any questions on the first piece of this function's derivative? Okay, now that we found the first piece, let's find the second piece. What rule do we have to use for the second piece?
Quotient rule.
Yep, now we use the quotient rule. Okay, let me erase this part. So we need to find the derivative of the tangent of x over x, and that is low, which is x, times d high. What's the derivative of the tangent of x? And that one you want to have memorized.
Secant squared x, or secant to the power of 2x.
Same thing, yeah, secant squared, secant power to 2. Either way is fine. Secant squared of x. And then minus, so we did high d low minus, low d high minus high d low, square the bottom and away you go. So we did low d high, now it's high d low. Tangent of x. What's the derivative of x?
1.
1. And multiplying by 1 is doing nothing, so I don't have to write anything. And then over x squared. There's not really any work to show on this one, but you have to know calculus to get it right.
So I did this one in a little bit of a different way. I did also just have a couple arithmetic errors because, you know, I don't get up early enough for this, but I switched all the secant and tangent into the component functions and then found derivatives for those.
That's much harder. So I strongly recommend you memorize the derivatives. Yeah. And on the exam, you might run out of time on the exam because they come up a lot and it takes more time. So on a quiz, it's just to remind you, you know, kind of good strategies of doing it. You miss a point or two, it's no big deal. The exam's different. So make sure that by the time the second exam comes along, you have the 6 trig functions derivatives memorized. Got it? And in fact, I'll tell you normally, because I don't usually teach this online. This is not an online class for me. Normally the quiz, it's a 6-question quiz in class. And what do you think the 6 questions are? What is the derivative of the sine of x? What's the derivative of the cosine of x? What's the derivative of the tangent of x? What's the derivative of the secant of x? What's the derivative of the cosecant of x? And what's the derivative of the cotangent of x? Because it is absolutely essential you have those 6 memorized. Got it? So, because we're going to be using it a lot, and it gets even worse. So let me tell you, and it won't be my problem, it'll be Bruce's problem. Next quarter, you do everything in reverse. So next quarter, if Bruce gives you the secant of x times the tangent of x, he's going to ask you what function had that as its derivative. And there's no way to go backwards other than having it memorized. Does that make sense?
Yeah.
Yeah. So you definitely, otherwise Bruce will kill me if I don't tell you, you need to memorize these 6. Because next quarter, everything is done backwards. I don't want to scare you too much. And I don't know if next quarter is harder than this quarter, but you have to have this stuff down. And then going backwards is no big deal. Any questions on that? Okay, but it's a good point. I'm glad you brought that up because it's important for me to let you know, yes, you can get away with what you did this quarter, but next quarter you won't be able to do that. And I won't be your instructor, so it's not me being mean. It's me giving you advice. You see the difference?
Yeah, I only even thought to do it that way because there was a homework problem that required that strategy.
I don't think so. Really? That doesn't sound right.
Yeah, I kept coming up with the wrong answer, and then there was like a video link directly from the problem, and it was like, break it into the constituent functions and then find those derivatives.
But you can always take the derivative, and especially once today is over with the chain rule, you'll be able to take the derivative of any function after today, other than exponentials, and that's another day. Okay, like 2 to the x we don't know how to do yet, but we'll get there. But you don't even know what 2 to the x is yet. You just think you do, but you really don't. Okay, so, and I'll convince you of that when we get to it. So any other questions on this one before we get to the next one?
Larry, did you say Bruce is teaching next quarter?
Yeah, Bruce and I switch off. So the
Cool.
idea
Okay.
is that way you don't get too tired of me or of Bruce. It's healthier to switch off back, to not have the same instructor for an entire year. Okay, and whether you get along with me or not, it's just reality, and it's good for you. Also, the university, you almost never have the same instructor twice in a row. So just let you know. So we're trying to also get you ready for university level, learning, and calculus is pretty close to university level. We're there. The biggest advantage I think at LTCC in a normal year is parking is easy. Wait till you get to a university. So there's some issues, and also our class is small. So Bruce will be teaching next quarter, and I teach it in the spring. Is the way we do it.
Awesome.
So that way you get it every other. You get us. Any
Cool,
other
thanks.
questions? Okay, let's find the 402nd derivative of the cosine of x. So that is find d402 over dx402 of the cosine of x. All right, here's the way you don't want to do it. You don't want to take derivatives 402 times until you're there. Okay, I purposely gave you an absurdly large number so you wouldn't even be tempted to do it, especially in a 20-minute quiz. So what do we do? What do you remember? What do you remember about the higher derivatives of the cosine? There's a special number. What's that special number? The pattern number. Yeah, 4. So we know that every fourth derivative, you're back to the cosine. Okay, and I proved that last time, if you remember. So every fourth derivative, you're back. So all we need to do is we need to find the remainder of 402 when you divide by 4. And I purposely gave you an easy one. I hope in your head you can all divide 402 by 4 and tell me what the remainder is. What is the remainder when you divide 402 by 4?
2.
2.
2. Notice that, 400. I try to make it nice. Right? If you knew what to do, this is easy. So this is the same, let me just type this out. This is the same as the second derivative. Which is, and now, what's the first derivative of the cosine of x?
Negative sine x.
So what's the derivative of negative sine x? And then we'll be there.
Negative cosine x.
Yep. So which is negative the cosine of x. And that's all there is to this one. So again, if you follow the strategy I gave you on Friday, this is a very easy question. If you didn't, then you won't have time to finish this. Any questions at all on this quiz? Any questions? Okay, so let's move on. And let me ask you, and hopefully my microphone, I don't know if it's working, but I'm trying to, if I end up losing my voice at the end, you'll know why, because I'm really talking loud. Hoping that might work. Is it working? Can you all hear me? Oh, good. Audible and intelligible. Okay, so that's a good sign. That's talking really loud. Hopefully that works.
Yeah,
Okay?
you're a little static.
A little static. Okay, because I really tried. I have a microphone I use for, headphones on my smartphone and stuff, but it didn't work on this computer. Bluetooth didn't work for it. So I'll have to see if I can find a plan B some other way, somehow. That's only I only have one portable microphone, so maybe at college I can find one if they let me in. But the bad news is one of the employees that works and is at the college, like goes inside, got COVID. So I think they're like locking the whole thing down now. Not sure, but I don't know if I'm even allowed in anymore. So we'll see. I'll do my best. Okay, so anyhow, are there questions about anything? Any questions? I do want to let you know the trig derivatives are very important in this class. They're going to be coming up over and over and over and over again. So, take it seriously. If there were any issues you have, you need to get that figured out. I can help you, the tutors can help you, but make sure that you can take the trig derivatives. And that means, of course, knowing how to use the product rule, the quotient rule, the power rule. Okay, that's the biggie. So I don't know if you've noticed, but you're not having to take derivatives with limits anymore. Now it's all using the rules. And today we have one more rule. All right, so let me give you an example of it. Right now, you know how to do it and you don't want to do it that way. So let f of x equal cosine of 34x. Any guess on what what we're going to be asked to do? It's the obvious.
Derivative.
Good, good. At this point in the class, you should all know, find the derivative is kind of what this class is about. And then after we know how to find all derivatives, then it's going to be use the derivative. Find f prime of x. Okay, so there is one way you do know how to do it. And I promise you, you would if I forced you to do it this way that I'm thinking, you would need Kleenex because of all the tears that would come down your eyes. And that is doing the double angle formula and sum of angle formula like 34 times so that you can break this up into lots and lots of pieces. You're going to have like serious multiple product rules. And you agree you do not want to do that. Okay, can you even imagine? I don't know if you can even imagine what I'm talking about. But in trig class, you learn how to do that, is how to break cosine of a number times x up. So we do not want to do it. Do y'all agree? That would be a disaster. So instead, what we want to do is realize this is a composition of functions, or can be looked at as a composition of functions. So we can say that we can look at this as f of g of x, where we're looking at, let's say, actually, let's call g of h of x because I already used an f. So g of x is equal to the cosine of x, and h of x is equal to 34x. Then f of x equals, and we can write this as a composition g of h of x. There it is. So g of h of x. So do you remember from algebra how compositions work? All right, so now what we want to do is we want to say, all right, we have this composition of functions, and how do derivatives work with compositions? And the cool thing is if you use Leibniz notation, then it's a lot easier to understand. Do you remember when I say Leibniz notation, do you remember what that means? So what's a Leibniz notation for a derivative?
That d over dx?
Yeah, that's that d over dx. Okay, whereas Newton's notation is f prime of x. And Newton's notation is less writing, but Leibniz notation is more informative, especially today. So let's look at this. So we can kind of change it. We can look at this the following. We can say, df over dx. Let me make that a little bigger. So we want df over dx, but the problem is we don't know how to find the derivative of f with respect to x. But we can write the following. We can think of this as df over dg d one more time. df over dg, let's write it a little bit differently. I think before I even write that, let's call g of x cosine of x and give it a letter. It'll be easier to understand. Maybe u. And we could say df over dx is equal to df over du times du over dx. Do you agree that this is true because of fractions? Okay, so I want to let you know that was a trick question because I knew you'd say yes. Okay, the answer is that the df over dx is not a fraction. Just as it's written that way doesn't mean it's a true fraction. So this is not a proof. In Leibniz day, actually, it was a fraction, but I will let you know, and it's beyond this class. We don't treat it as a fraction anymore, and there are reasons, but I can't talk about it. It has to do with the infinitesimals in existence. I'm just not going to go there. So instead, we got to be careful about treating it as a fraction because that doesn't sound right. Okay? The good news is it still works. So even though this is not a proof, this is a guideline to what we need to do. Any questions on that? Okay, so oh, you know what? Sorry, I have this wrong. I knew I made a mistake. If g of x is cosine of x, h of x is u, which is 34x. So then we can think of f as g of u. See how that works in the composition? All right, well, now what we can do is we can work this out. Okay, so now we're looking at the cosine of u. So let's write down equal, and df over du. So that means the derivative of f with respect to u. So f now is just cosine of u. And what's the derivative of the cosine of u?
Negative sine u.
Yeah, negative the sine of u. So I do want to let you know that the number one mistake that people make is using x instead of u right here. It's not negative sine of x, it's negative sine of u. Got it? So what is du over dx? What is the derivative of u with respect to x if u is 34x? And that's even easier.
34.
Yep, 34. Any questions so far? Okay, now we can just clean it up. That is negative the sine, and now u is 34x times 34. And to clean it up a bit, which I think it's worth doing, that's equal to negative 34 times the sine of 34x. Which I know it's not showing, but it will in a moment. Well. There we go. Any questions at all on how I work this out? Any questions? Okay, so notice that the inside function is 34x. The derivative of the inside is 34. The outside function is cosine. The derivative of the cosine is negative sine, but you don't put x in, you put in u, which is 34x. Any questions at all on how that works? Okay, so this is called the chain rule. And again, right now you're just trusting me that it works, but we should prove this because this is This is a big, big formula. I will let you know that if you do not get the chain rule and understand it and being able to fully use it, you will not pass this class. So this is one of those where don't just say, oh, you know, this is a hard day, but it'll go away. So I don't know, I'll just learn next time. I'll just forget about it and we'll learn about whatever's coming up. This is one you have to get. So we're spending, you know, the whole day on it because this is a biggie, even though we actually have a lot of time. There's not too much to talk about today, but we need to practice a lot because this is one of the most important topics of all of calculus is the chain rule. Okay, and I'll show you harder questions too, but this is one. And again, in math, it's always easier to watch your instructor do it than to do it yourself. Okay, so let's look at the proof. So we want to look at the proof. So whenever we're proving a derivative, what must we use? Yeah, we have to use a limit definition. But the good news is, it's my job to prove, okay? Because if I asked you to prove it, you know, and you couldn't go do research or anything, I don't think any of you would get it. This is one of those really tough ones, as in you need a rabbit to come out of the hat and all of a sudden things will be wonderful. But that's what we're going to do. But having this Leibniz notation helps. So the first thing is, let's write down what we're looking at. Well, we're looking at, as you mentioned, we're looking at the limit. And now I'm going to bring about something that you may not remember because it was weeks ago. And that is there were two limit definitions that both worked of the derivative. One of them was the limit as h goes to 0 of f of x plus h minus f of x all over h. Now open this one up. Does anybody remember the other definition, the equivalent definition? Okay, so limit as x goes to c. Okay, good, good. So we're going to take the limit as x approaches c, and now there's more to it, of course. And now we need a fraction. And what is the numerator of the fraction? I'll start you off. F. You remember? So it's f of, but now it's going to be g of x. Or actually, I guess if we're going to be writing it like the way I have my example, it's going to be g of h of x minus, and then what is it going to be? It's going to be g of h of x minus g of h of c over x minus c. Does that ring a bell? We just had f of x minus f of c over x minus c, because that was kind of the secant line way of thinking about it. But this is putting it together with composition. Any questions on that? Okay, so one way of thinking about this is realizing we want this to go on. We want df dx equals df du over du dx. And right now we only have a numerator and a denominator. So what we're going to want to do is we're going to need to multiply by du over du to get that du in there. Any questions on that? All right, so what I'm going to do now is I'm going to multiply by the following fraction, the one fraction. You're always allowed to multiply by 1. And then multiply by h of x minus h of c over h of x minus h of c. Are you all in agreement that you're allowed to do that? Everyone good with that so far? Okay, and the reason I did it is what I just did is multiplied by I multiplied by the du over du. So that's what just happened. Because the h of x minus h of c, that is the change in h. And h was u. You see how that works? So even though it may feel like I pulled a rabbit out of the hat, the reason I gave you this example first was for you to recognize the rabbit. And maybe it worked, maybe it didn't, but at least I can try. Okay, now the next step is easy. And that is, let's compare again, because we're after this df over du times du dx. And right now we have df over dx times du over du. So what should I do? The hint is it should be pretty obvious. Any thoughts? And it's an easy step. Easy, obvious step. Oops. Okay. I don't want to cancel. The whole point is I wanted to introduce this h of x minus h of c over h of x minus c. I'm just going to switch h of x minus h of c. And I'm going to put that one in the first denominator. And then in the second denominator, I'm going to have x minus c. Nothing magical. And that is to make it look more like df over du times du over dx. Any questions on that idea so far? Okay, so it's an easy step, but an important one. Okay, so the next thing I need to do is the following. I need to break this up into 2 limits. And when we learned about limits, we learned that you're allowed to do that. Any questions on taking the limit of the product and turning it into the product of the limit? Okay, and there's something I didn't mention, but technically I should. We're assuming that everything is differentiable. If it's not differentiable, you can't do that. But we're going to assume it's all differentiable. Otherwise, it's just worthless. You can't do the derivative. And you just say, forget it. Okay? All right, now let's look at these 2 pieces. And what are they? Well, the first is we can think of this as g of h of x minus g of h of c over h minus c. But now the h is the variable. So this is going to be the derivative of g with respect to h. Sometimes you call that g prime of h of x. And then the second one, limit as x goes to c of h of x minus h of c over x minus c, that's h prime of x. And that's the full proof. Any questions at all on the proof of the chain rule? So again, I want to highlight the fact that this is h of x, it's not x. So you're not plugging in x into the derivative, you're plugging in h of x. And that's where people make mistakes. So promise me you don't make that mistake on the exam. Because it is usually about 30% make that mistake. And don't be one of those 30%. So I'll keep saying it to make it so that maybe this year it'll be 0% make the mistake. Okay, so at this point, the great news is that other than exponentials, we could take a derivative of anything now. So let's just do an example. How about let f of x equal the sine of the cosine of x. And the question is, find f prime of x. Or let's call it df dx. So here's what I'm going to do. I'm going to give you a minute, shouldn't take more than a minute, to find the derivative of this guy. Let's see if you can do it using the chain rule. So I'll give you a little time. And then when you're done, put it in the chat box and see if you get it right. Okay, I do want to let you know parentheses are important. And so be very careful. And if you're ever a computer programmer and you have four open parentheses and 3 closed parentheses, you have what's called a bug. And in this particular problem, it's very hard, you know, the parentheses are actually really important. And in this problem, it matters. Okay, and the hope is everyone can get it. I want to see more than one person try. You should all be trying, by the way, and there's a lot of you here. So put in the chat box when you're done. So what is the derivative of the sine of the cosine of x? Okay, good. We have a couple answers, and most of them are the same, but we got to be careful. Okay, so let's take a look. So the first thing, and what I'm going to do, I'm not sure if it lets me, is I like to underline the inside. See if it lets me do that. It may not let me. Maybe one of these guys. Okay, can't underline, but I can highlight. How's that? Make it red. When I'm doing it on paper, it's different than the computer. What? Okay, so it's not letting me make it red. How about underline? Okay, so sorry, that didn't work. All right. See that. Nope. Okay. Well, pretend I did. Okay, so the idea here is we have the inside, and I like to take the derivative of the inside first. And the derivative of the inside, what's the derivative of the cosine of x?
Negative sine x.
Negative sine of x, good. So f prime of x, or df dx, is equal to negative sine of x, and then times, and now I want to take the derivative of the sine without saying a letter. What's the derivative of the sine without saying without using a variable? Yeah, just cosine. And then I'm going to put some parentheses in. And then I think, what goes in the parentheses? What goes in the parentheses is the inside. The inside is the cosine of x. And then I'm done. Any questions at all on how I approach this guy? And I want to let you know, I think it's going to be easier for you if you go from the inside out versus the outside in. One reason is it turns out the notation is prettier. There are fewer parentheses to deal with. The sine of x, had it been on the other side, it's hard to see whether it's in the cosine or not in the cosine. But the way I've written it, it's really obvious. I hope it's obvious to everyone. And I want to let you know another thing, because I want to make sure that those who make small errors understand their errors. Cosine of the cosine of x is not the same thing as cosine of x squared. So cosine of the cosine of x is by definition function composition, whereas cosine of x quantity squared is function multiplication. And multiplication and composition are different. Got it? So very important not to get those two things confused. So a lot of places that can go wrong, and some of it's just simple notation. It can be hard. Okay, a lot of things going on here. Any questions at all on this example? All right, I have a challenge for you. Okay, you're not allowed to do exponentials. It's one thing we're going to keep away from. So you can't say 3 to the x. And that is, can you come up with a function that is differentiable that we don't know how to find the derivative of? That isn't an exponential. Or a log, because that's an inverse exponential. So are there any functions left that we don't know how to do? 2 to the x is an exponential, so that's not allowed. I said other than that, that's another day, by the way. Are there any functions you can think of that are not exponentials or logs, that are differentiable that we don't know how to find a derivative of? Give you a little bit to think about it because it's important. Okay, roots. Okay, then give me one that we can't do. If you think roots, because roots definitely not an exponential. So give me an example and let's see if we can do it. And again, put in the chat box is the easiest. Give you a minute. Okay, sine of this, and when you say root 2, my guess is you mean square root of 2. Actually, that one's interesting. Let's do it. It's a trick question. I don't know if you meant it to be a trick question. So consider f of x equal the sine of the square root of 2. Find f prime of x. Okay. And here's a hint. I'll give you 2 seconds to come up with the answer and put it in the chat box. That's all it should take. Okay, yeah, the answer is 0. Right? The answer is 0. The answer is just 0. Why is the answer 0? We have a constant. Derivative of a constant is 0. There's no x's. The derivative is 0, period. Got it? I'm not sure if you were thinking about that when you came up with your question, sine of root 2, or maybe you wanted to give a trick question. But that just has 0. So the answer is just 0.
Larry, if it was, aren't you finding the derivative of sine, which would then be cosine, then you multiply, or would it be cosine of 0, which is 1 though? Or am I thinking about that too quickly?
Okay, so where's the x in this function? It's a trick question, but I didn't give it. There is no x, right? So if there's no x, this is a constant function. Yeah, sine of 1.41, etc. You can put that in a calculator to get a number. And then notice that that's a horizontal line. And a horizontal line has slope 0. Okay, that's kind of the little bit more rigorous way of doing it. But easier is just the derivative of a constant is always 0. Okay, maybe I'll give you one with the root. Let's try it. Let me give you a harder one. And let's see if you can do it. So this is going to have x's in it, by the way. The answer is not going to be 0. Just a warning. So if, not yet. If f of x is equal to, how about the sine of the square root whoops, not yet, the fraction square root of x over 1 minus 2x. Find, as you might guess, f prime of x. Okay, and again, I think it's important that you try it before I show you, because that's when you're really going to learn. Because I've really done all the main theory today. There's one little item to do. It's not new theory, but it's something that you may not think about. But this problem you know how to do, at least if you've been following everything I've done today and in the past. And by the way, do not write limit as h goes to 0. That would not be fun at all. So give you a minute or two. This one's a little harder. It's a lot harder than sine of root 2. It just was a 2-second problem. This one takes some work. I like to go inside out. So start with the inside and then at the end do the outside. Especially when there's trig, because when you have trig and then after it you have something, it's hard to see whether that after it is inside the trig or outside the trig. So if you take the derivative of the inside first, then it'll be to the left of the trig and it won't be confusing. I don't know if that makes sense to you, but that's my suggestion. Okay, technically you could do either way, but the inside tends to be a little less confusing in terms of your written answer. Especially when the sign is, the trig is outside. So again, this will take a few minutes, not 2 seconds, by the way. If you write 0, it's wrong. Okay, I'm a little worried. If you don't have something very messy, it's not right. I know that sounds weird, but that's the truth. There is no nice way of writing the answer. Yeah, so I can read all the parentheses on Rigney, but at least it's messy, so that's a good sign. Okay, let's work this out. All right, so let's start with the derivative of the inside. What rule do I have to use to find the derivative of the square root of x over 1 minus 2x? Yeah, that's the quotient rule. So let's do the quotient rule. And that's low, which is 1 minus 2x, times d high. Now the derivative of the square root of x, remember square root of x is x to the 1/2, and the derivative of x to the 1/2 is 1/2 times x to the negative 1/2. Because 1/2 minus 1 is negative 1/2. And then you do minus, and then you do the high, which is the square root of x. I'm going to put that second because it's better to have the square root at the end, times d low, and d low is -2, so I get plus 2 times the square root of x. Square the bottom, and the bottom is 1 minus 2x squared, and away you go. Any questions on that part? Okay, times. Now it's the derivative of the sine, and the derivative of the sine is the cosine. I think the easiest is just copy and paste this guy and change the sine into a cosine. Oops. And that's the answer. Do I need to simplify it?
Larry, you get rid of the minus between 1 and 2x
Oh, I lost it. Let me see. I think you're right.
at the end.
Where?
You have over 12x.
Oh, yeah. It's definitely not over 12x. That's weird. I tried to copy and paste, but I guess it didn't paste right. There we go. Question? And there's no work to show. That's the weird thing. You know, we just do it. But it's real obvious if you get it wrong. Any questions at all on this? Can you simplify? All right. Is that something you enjoy doing in life? Like, would you rather simplify than, I don't know, hang out on the beach? Okay, then why would you want to simplify? Remember in my class, once you don't have any derivatives, we're done. Okay, so maybe it could be simplified, but I don't even care. Okay, what I care about is we got the answer, we have no calculus left, and now we're good. Okay. Any questions on this example? Okay, now the next one's, actually before I do the next one, I want to do something I didn't do 2 times ago. And I said I didn't do it because I can do it now. And that is the quotient rule. So if you remember, I never proved the quotient rule. And the reason I didn't is because it's a whole lot easier to prove the quotient rule after you have the chain rule. So proof of the quotient rule. And the nice thing is I don't need to use a limit definition because I have a chain rule now and the product rule. So what we have is we want to take the derivative of f of x over g of x. And what I mentioned is we can do this as a proof without using the limit definition. And the way we do that is we can rewrite this as the derivative of f of x times g of x to the negative first power. Do you all agree that those are equivalent? That that's what negative first power means? So now what can I do? What rules of differentiation can I use to find the derivative of f of x times g of x to the negative first? Any ideas? Product rule and, so product was one of them. What else am I going to have to use? Power rule come, but what else? The one I was thinking, chain rule. So the idea is we can now use the product, the chain, and the power rule all together. So we can now just write down the answer. Well, we take the product rule says the derivative of the first, which is f prime of x, times the second, which is g of x to the negative first power. And then it says plus the first, which is f of x, times the derivative of g of x to the negative first. Well, to get the derivative of g of x to the negative first, I use the chain rule. And the derivative of the inside is g prime of x. And then the derivative of g of x to the of something to the negative first is negative that thing to the negative second. So g of x to the negative second power. Any questions so far? All right, we've done the calculus. Now we need to do the algebra because we're trying to prove the quotient rule. And the key here is, what is the common denominator? And remember, negative powers means it's in the denominator. Anyone see the common denominator? It's a little hidden because we have the negative power. Okay, it's not g of x. Good try, though. There's something higher than that. Here's a hint. Look far right. Yeah, it's g of x squared. Because we have g of x to the negative 2, and that comes down as a g of x squared. So to get a common denominator, notice I'm going to have to take this f prime of x, g of x to negative 1, and multiply it by g of x times g of x to negative 1, and I get f prime of x times g of x. And that way I get the g of x to the negative 2 that I need for the common denominator. Minus f of x times g prime of x over the common denominator, which is g of x to the squared. And that's the quotient rule. Low d high minus high d low, square the bottom, away you go. It's the same thing. I wrote it as d high low minus high d low, square the bottom. That's the same thing. Any questions on the proof of the quotient rule? Okay, now comes the chain rule at its finest. When you think of the word chain in English, what do you think of? Yeah, interconnected parts. Okay, and the idea is when I think of like picture in my mind a chain, I think of a whole bunch of little links together. You see that? Now, all we have done is 2. So the reason why you call it the chain rule is you can do it with many links. So let me give you an example. Let f of x equal the sine of the cosine of the tangent of the secant of x. Find f prime of x. Any questions on the question? Okay, and the idea is now we have not a 2-linked chain, but a 4-linked chain. You see that? And the key on this is if we go inside out, then everything will come together. So let's start with the secant of x. So f prime of x is equal to, well, what's the derivative of the inside? What's the derivative of the secant of x?
Secant x times tangent x.
Good, secant of x tangent of x. Then times the derivative of the tangent. But don't say the letter x. What's the derivative of the tangent without saying x?
Secant squared.
Yep. Secant squared, but not of x. What's it of? What's its inside?
Secant x.
Mm-hmm. And then times, again, inside out. So now we're really inside out with lots of insides and lots of outsides. So we just finished the tangent. Now we're on the cosine. What's the derivative of the cosine?
Negative
Negative
sine.
sine. And I can put the negative all the way out. Just looks a little prettier. So it's going to be times the sine. But what's the inside? So it's the sine of what?
Tangent of the secant of x.
Yep, the tangent of the secant of x. And then times the derivative of the sine. What's the derivative of the sine? Important, you all know that
Cosine.
one by heart. Yeah, cosine. And then what's the inside?
Cosine of tangent of secant x.
Yep, cosine of the tangent of the secant of x. And there's the answer. Any questions on this example? Yeah, what a big chain. Do you think this ever happens in the real world? Something like this? Okay, no, this is math fantasy. Okay, but I will let you know things like the tangent of the sine of 2x. Do you think that happens? And that's a yes. And in fact, I can tell you, it happened personally to me this morning. I know that sounds weird. I don't know if I mentioned the way I start my day every day. But when I start my day by watching a lecture, okay, I'm a forever student, I guess. And I don't get units or anything. I don't need units anymore. But I like to always learn. And I'm going through a communications course. Okay, and not like sociology communications. This is how, you know, this is like hardware and all the math behind it and how communications works in terms of FM radio and what the machinery does and stuff like that. And the professor, and that was at Florida, went through and talked about the way it works, and he had a sine of a cosine of a function. So he had a 3-link chain. I've never seen more than 3 links. But he had a 3-link chain, and if you don't have that, then you won't understand how the equipment works to submit radio signals, if you want to submit radio signals or cell signals. So it was all part of that equipment, and it was pretty cool. But it was very, very like complex, messy trig math. Okay, which I understood, but it was messy. So I'll let you know this does happen. Let me give you another example. That's all we're doing today is examples. Let's suppose that f of x equal, how about the square root of x squared minus the cosine of 2 minus 3x. And as you might be able to guess, find the derivative. A little big. That's better. I'm going to give you a moment or two. Should take a couple minutes. And let's see if you can find the derivative of the square root of x squared minus the cosine of 2 minus 3x. And again, give you a minute. And the hint is you will need to use a chain rule in an interesting way, or a couple ways. And I will let you know, very easy to lose a minus sign. There's a lot of negatives in this one. This one's not too bad. Nothing like the one I just did. Okay, let's take a look. Let's take a look. At least we have one guess in there, or one try. So what I like to do, very first thing is I like to get rid of that square root and just turn it into a 1/2 power. It just works a little better for me. And now I can start working this out. So I need to use a chain rule. So I need to take the derivative of the inside. What's the derivative of x squared? That you should all know by heart. That should be easy for you. What's the derivative of x squared? 2x. Okay, now I need the derivative of the cosine of 2 minus 3x. What rule do I have to use for that derivative? In a word.
The chain rule?
Yep, I use a chain rule. So you got to really think about these one at a time. So the derivative of 2 minus 3x is -3. So I get a -3, and it's a -3. That makes it a +3. And then times the derivative of the cosine. The cosine is negative sine. That makes it a minus again. You get a lot of minuses. And then sine of the inside, which is 2 minus 3x. So we now just found the derivative of this inside. And what makes this a little hard is that there's two different kinds of insides here. Then we multiply by the derivative of the outside. The derivative of 1/2 to something is 1/2 times that something to the -1/2. I could put the 1/2 outside completely. And now I can take this whole thing and say that's to the -1/2. And that's the answer. Did I lose anyone there? Are you able to separate those two, the x squared and the negative cosine of 2 minus 3x? So I'm not exactly sure what you mean by separate. I definitely took the derivative separately, if that's what you meant. But what you can't do is you can't say it's x squared to the 1/2 and then minus cosine of 2x minus 3 to the 1/2. That would be wrong. So it depends on what you mean by separate. What you can do is what I did is I said I'm going to take the derivative of x squared first, which I did, and I got 2x. And then I'm going to take the derivative of the cosine of 2 minus 3x, and then subtract, and that's the subtraction rule for derivatives. And that you're always able to use a subtraction rule. Okay, one last quickie, because I want to make sure you're all okay with this. Let f of x equal, and we have a fraction, 2 over x squared minus x plus 3 to the 5th power. And I guess I should write, find f prime of x. All right. What should I use? Again, strategy time. What rule do I need to use? What do you think? Okay, I particularly asked this because I knew you would say quotient rule. And the answer is you don't need to use the quotient rule. So what I want to remind you is there's another way of writing a constant over a power of something. And it's a much easier way when you're doing calculus. And that is you write it as 2 times x squared minus x plus 3 to the negative 5th power. Any questions on that bit of algebra? And that saves a lot of time if you do it that way. So then f prime of x is actually quite easy because we use the chain rule instead of the quotient rule. Do you all agree the chain rule is not as messy as the quotient rule? Okay. So now I take the derivative of the inside, which is just 2x minus 1. I still have the 2. And then I take the derivative of the outside, which is negative 5, so that 2 becomes a negative 10. And then times x squared minus x plus 3 to the, and what's negative 5 plus 1? I'm asking you because it's a mistake some people make. Yeah, that's why I asked. What's negative 5? Sorry, minus 1 is what I meant. Yeah, what's negative 5 minus 1 is what I meant because that's what we're doing, is negative 6. And there's your answer. And that's a whole lot easier than the quotient rule. Do y'all agree? So kind of the punchline is that whenever you see either a numerator or a denominator that's just a constant, don't write it as a quotient. Write it as a product. Got it? Makes your life much, much easier. So quotient rule, you only want to use when you have a numerator and a denominator with x's, and the denominator is not just a power of something. So even if had this been 2x, you still would want to bring this to the negative 5th, and it's still much easier. So whenever you have the quotient, the denominator, as a power, use the chain rule. And life is easier for you. It's not wrong to use the quotient rule, but it's a whole lot more work. And now we're done. So I want to stop my share and stop the recording.